Hello, everyone. Welcome back. This is going to be the final lesson on chapter 13, which means, like most of these chapters ends, we're looking at some form of applications of these ideas we've been looking at. For the applications lesson, I think you guys should find this somewhat okay. The main skill for a lot of these application questions is being able to draw our graphs. So as long as we can graph sine, cos, tan, we should be okay with really any of these application questions that pop up. This question here says the height in meters of the tide above mean sea level at a harbor entrance over 1 day is given by the rule H brackets T is equal to 3 sine pi t on 6, where t is the number of hours after midnight. Always a good idea to establish where my time is starting from. I have seen a lot of these questions that start from like 6 a.m. or 3 a.m. So just pay attention to where this begins, because it's going to help allow you to turn these hours into actual times. Or if you're given a time, you can figure out how many hours that is going to be. In this case, my function is going to be equal to 3 sine pi t on 6. So my first step is going to be to find t, which is going to be 2 pi divided by pi on 6. Keep it, change it, flip it. That's going to give 2 pi times 6 over pi. My pi's are going to simplify to give 1. 6 times 2 is going to give 12. So I have one full wavelength over a 12-hour period, which is true for tides, because tides occur every 6 hours roughly. And if I have one full day, if it's between 0 and 24 hours, that means I'm going to have 2 full wavelengths. So again, just putting my period in the context of my domain. Looking at my graph, I don't have any phase shifts. I have no vertical shifts. I do have an amplitude of 3. So really all I needed to know was my period to do my sketch. Starting from 0, it's a sine function, which means it's going to start from the equilibrium. It's going to go up 3, it's going to go down 3, it's going to be at -3 and +3. Again, we have 2 full wavelengths, so let's just put that on my graph, something like that, and we'll try to give myself a little bit of a longer line here. Perfect. Okay, so I've got my wave. I now just need to mark my key values. This is going to be 24 hours. This is going to be 12 hours. If I do t over 4, well, my period is 12, so my critical points or my key intervals is going to be 12 divided by 4, which equals 3. So that means I have a critical point every 3 hours, 6, 9, 12, 15, 18, 21. You know, and I think it's sometimes easier to do these in terms of time than it is to do these in terms of pi. So that's my graph. That's going to be 4 marks there. I should label my axes. Let's just label it this side. And now I'm going to get 4 marks. Once we've got our graph, almost the rest of this is just going to be interpreting the function that we've sketched. So if I want to figure out when high tide was, that's going to be at my peaks. So I have a peak at 3 hours. I have a peak at 15 hours, just here and just here, which means I'm going to have a high tide. Just write peak 3 and 15. So therefore high tide at 3 a.m. and 3 p.m. or 1500 if it's 24-hour time, which is 3 p.m. Part C says, what is the height at high tide? And the height is just going to be the amplitude of my function, which is going to equal 3 meters. Part D asks for the height at 8 a.m. If I know my time starts from midnight, that means my number of hours here is going to be 8. So now I'm going to sub in 8 into my original function, which is 3 sine. And now my substitution part here is going to give me the number 8. If I simplify my fraction, that's going to give 3 sine of 4 pi on 3. I know because it's over 3 that I'm going to use my pi on 3 exact value, which is going to become 3 times sine of pi on 3 is root 3 over 2. And because it's 4 pi on 3, that's going to become -3 pi over 2. And there's kind of a rough sketch to give you an idea of where 4 pi over 3 is, just in case we were struggling to understand why that was negative. Sine is negative in quadrant 3. So this is going to give me a final answer of -3 root 3 over 2. So that is going to be the height at 8 a.m. For part E, it's a little bit more wordy. It says a boat can only enter the harbor when the tide is at least 1 meter above sea level. When could the boat enter the harbor during this particular day? So I'm just going to edit this sketch over here. if the boat can only enter the harbor when it's at least above 1 meter, that is going to be 1 meter or 1 in terms of my y coordinates. So I should get 4 times just looking at my picture. And the time is going to be between these 2 points. So if that's the case, I'm going to use my calculator to type in my function. That is going to be 3 sine pi x in this case, because I have an x-axis, not a t-axis, over 6. So if I do that, I've got my graph. Let's come across till I can see 2 full wavelengths, which is there. Now I'm going to graph the line of y equals 1. Once I've done that, I'm now just going to find my points of intersection between those 2 lines. So I go ahead and I select this point and I keep doing this. Once I've selected all 4 points, I'm going to move them into a spot that makes them nice and easy to read. This is going to be the 4 sets of hours where my tide is above 1 meter. Now I do need to convert these into time. So if I write these out as times, I have 0.649. Let's just put our numbers down, 0.649. And from my graph, I also had 5.35, 12.6, and 17.4. So there's my 4 times. I now want to convert each of these into hours. To convert each of these into hours, that's going to be 0.649 times 60, which is going to equal 38.94. So therefore, that's going to be at 39 minutes past midnight. Or if I put that in 24-hour time, 0039. If I do the same thing to my second one, well, I know I have 5 hours. So I just want to convert the 0.35 into minutes. If I times 0.35 by 60, I get 21 minutes. If I continue doing the same thing, I'm going to wind up with the following times. That's going to be 12:39, and that's going to be 5:21 or 17:21 if I continue to put these as 24-hour time. So therefore, the boat can only enter between 12:39 a.m. and 5:21. Can only enter between 39 minutes past midnight, 5:21. And my second one is going to be 12:39 and 5:21 p.m., or you can put them in 24-hour time. So that is essentially it for our trig graph. Let's just do a quick recap of that for our applications. So step 1 is to do our sketch. Again, you can think about your key values we need, our critical points, our amplitude, what my function is going to look like, the period. Once I've got that, the next 2 really were interpretations. What's the height? When is high tide? Question 4 required us to do a substitution. And then part E required us to do use our calculator to do the intersection between graphs. Just know there may be ways to do this in a tech-free fashion. If I establish my equation, if I do HT equals 3 sine pi t on 6, and I let my height equal 1, so I get 3 sine pi t on 6 equals 1. If I divide both sides by a third, I get sine pi t over 6 equals 1 over 3. So because I get 1 over 3, in this case, if I have a calculator, it's going to be tech active. It's relatively straightforward. However, if this gives me an exact value, I may be able to find an exact value for t, in which case I could do a question like this in a tech-free format. If I have exact values, I should get nicer values for my hours, which will make it easier to convert into times. So just note, whilst we did do this one tech actively, it could also be done in a tech-free fashion by essentially just solving this trig equation between 0 and 24 hours. Okay, hopefully you guys found this helpful, and I will see you in class.